You know, Amelie, I've been thinking.
This can't be good. It's off on a tangent.
I'm sick of this tape player.
You just got it last week, Jimmy.
No, I'm sick of the idea of a tape player.
Have you been eating those Pop Rocks again? I'm telling you, they've got to cause cancer. The way they crackle and pop like a chemistry set in your mouth.
It's just not working for me. Let's say I want to listen to some Winger, but then I kind of feel like craving for some Wang Chung.
Is that what the kids are calling it these days?
I have to take out one tape and then put in another one. Or what if I wanted to listen to two songs on the same tape, but they don't come after one another?
You'd have to fast forward?
Of course, but that takes a long time, and you can overshoot the song that you want pretty easily. Now, you don't want me to go off on a tangent about fast forwarding.
Oh, no, please, no. Just make a bunch of mixtapes.
For each time I listen to music, my entire world will be mixtapes before long. And what if I wanted to do something else, like watch a music video? Can't do that on the tape cassette.
Yes, you have a point.
I wish there was some device that could let you play the songs when you want them to. Nah, that's probably impossible.
No, I couldn't help but overhear you guys talking.
Hey, who are you?
I'm Steve Jobs, president of Apple Computers.
Could I ask, what are you doing here?
I'm not really allowed to talk about it.
Is it Fight Club?
No, no, I don't. Wait, what?
Does it have to do something with your hard-partying lifestyle, perhaps?
No, I'm actually Wozniak's right at the Elks meeting. Anyway, I was making up some sketches for this new music device that is going to revolutionize the music industry. I'm thinking of calling it a disco pod. What do you guys think?
How's it gonna work? Is it like going to have a bunch of tapes in it?
It'll be about the size of your palm, and it'll have all the stuff, all the music on a computer disk, and you'll be able to play a single track at a time in any order you want. Plus other great stuff, like video, or games, or stopwatch, maybe even a phone.
That's insane. It's not possible. If it were possible, Xerox would have done it already.
Hey, I didn't steal everything from Xerox.
Name one thing you didn't steal from Xerox.
But what am I, on trial here? Give me some slack.
You even stole the corporate logo from Xerox.
Okay, maybe you're right. But at least I didn't steal this from Xerox. Really, I didn't.
So anything else on the horizon, Steve?
Well, this conversation got me thinking. I cut a lot of code, you know, and I wish there was some sort of definitive collection of solutions to common design problems. This could be one. You know, what if you want to choose between a couple of different algorithms at runtime, like choosing between songs, like picking between strategies? That's it! The strategy design pattern. It'll be huge!
What, did you steal that from Xerox too, Steve?
For the last time, they stole everything from other people. And anyway, even if those allegations are true, you still have to cut me some credit.
Why?
Because unlike Xerox, Apple Computers isn't synonymous with that thing that breaks down in the office that everybody hates.
You have a point.
It sometimes happens that, instead of having a program run through a predetermined list of operations, we would like to be able to tell the program what we want it to do at runtime. This concept, in a nutshell, is the basis for the strategy design pattern. This is a lot like the difference between the tape player and the iPod. With a tape player, the order of the songs to be played is static. That is, the order is set and cannot be changed. With an iPod, the order of the songs is dynamic. You can select them as you go, on demand, without any predetermined order. This analogy is not perfect because you can fast forward or rewind a tape to get to the song you want. This doesn't change the underlying reality that a tape has a predetermined order of songs that cannot be changed, and the tape player designers had to include a workaround, a hack if you will, to make the product a bit more user-friendly. Let's take a closer look at the architecture of the strategy pattern. Let's keep in mind that these classes have different names in different sources, and that there is no reason why they'll have the same names in a program that they do here. Nevertheless, the strategy pattern will always have the three following elements, which will be described as follows. The first part of the pattern is the context. It can be thought of as the main class or the driver in the program. It does not necessarily have to be either of those, but it is where the decision on which strategy to use is going to occur. The next part is the eponymous class strategy. More accurately, strategy is an interface that specifies the methods that must be implemented in the classes amongst whom we will choose to run. This particular element is necessary because, as has previously been mentioned, we don't know which class is going to be chosen to run when we start the program. So, classes implementing this interface will be certain to contain the methods that we want, thanks to the miracle of polymorphism. The next part of this pattern are the concrete strategy classes. These classes implement the strategy interface, and they will be the classes among which the program, in the context class, remember, will select. To sum up, interaction between these classes is as follows. The context will take in some data from the user and, through some process, decide which concrete strategy to run. The context will then call a method in the concrete strategy class, which will be there because it implements the strategy interface, thus giving us what we want, dynamic runtime access to whatever algorithm we want to run.
Alright, let's go through a quick example.
The first class in my project is the processor class. This is a class that drives the program. It's where the user specifies the text file to read, and it's where the user specifies which action that he/she wants to take with respect to the document. The decision of what to do occurs in this part. This class uses an if-then-else chain, and then initializes an instance of the appropriate class.
Here is the next part of the project, the text operation interface. This interface just specifies the method that all of the classes that will perform an operation will need to include, the initiate method.
And the final parts are the word count, replace word, and print preview classes. They all implement the text operation interface, and they contain the initiate method specified in the text operation interface. So now a quick exercise. I've shown you my code, but can you identify which parts of my code match up with the components of the strategy pattern? I'll make it easy on you. Just match up the 3 components of the strategy pattern with the 5 classes we mentioned, with no doubling up. Just kidding. If you want to look at all the code, it's available at... Please pause the video and enter your questions in the questionnaire.
So here are the answers. Processor is the context, since it is where the decisions are made. Text operation is the strategy, since it is an interface that the concrete strategies implement, and it contains the method that the context is going to call. And finally, the concrete strategies are word count, print preview, and replace word.
This concludes the explanation of the individual parts of the strategy pattern.
For this exercise, your goal is to refactor some existing code to use the strategy design pattern. As it stands right now, the calculator class takes in 2 numbers from a user and then performs a couple of operations on them. We want to allow a user to select an operation to perform on the numbers instead of having those operations predetermined. Please look at the existing code that you can find at this website on the screen and refactor it to use the strategy pattern. Good luck, and please keep this video paused until you're finished. Alright, time's up. If you created a class for each method and created an interface that each of these new classes implemented, and then tweak the code in the main method to invoke these classes via that interface, I think it's safe to say you're on the right track. Thank you for your time, and we'll see you later.